So we talked about in EMR3, we had an agenda, we talked about encryption, and we talked about job configurations, and we had a framework, if you remember the encryption, at rest and in motion, and we talked about a cluster configuration, a 24/7 cluster, and then we discussed how it all comes into play as a job flow and the overutilization, underutilization. And then we discussed about the Spark configuration and the monitoring. And we introduced we took the cluster homework as an example to try to implement this into a framework with all the different steps, so it will be easier to consider once you configure a new deployment. And we didn't touch upon the second example, but I want to try and start playing with the real cluster in a real life scenario. So everything here we will connect to a simple cluster deployment. Hopefully it will all connect and will all make sense. Again, I think nothing will be perfectly clear, but we are here to talk about things as much as we need. And there's no real agenda except having you understand as much as possible from what we're trying to achieve here. So any questions before I start? No. Okay. So I'm going to share right now my AWS account. So I assume you all know by now EMR console. Correct me if I'm wrong. Okay, so what you can do is essentially, let's go to a different empty, let's say Ohio, different region, EMR training cluster. So we have here the EMR session. We have lots of options in the menu, but we're going to cover only the cluster section of creating a new cluster. You can create a cluster. You have a default setup over here. We're not going to go over the default setup. We're going to go over the advanced one. Okay? So what we have here, the first step, as you can see on the left, you have 4 stages. Would be software and steps. So the first step in software step is software configuration. Notice you have lots of releases. You have EMR5, EMR6, and sometimes you have even better releases over here. You can always choose the most advanced, especially if you're starting a new project, so you don't have to perform some backwards compatibility code maintenance. You can select here all the different technology. Notice the list is quite long. And on top of that, the list keeps getting longer and longer over the years. Not only that, the different versions are upgraded as the different versions of EMR keep going up. For example, Hadoop version 3, Spark version 3, and so on and so forth. Any questions about this section? Would you like to talk about the specific technology a little bit more?
PyTorch is supported?
PyTorch. I think it's a package you can install on Jupyter. I don't think it's...
No, it's like TensorFlow. It's like...
I know. It's not... I just don't think it's out of the box installed. You need to install it.
Okay.
In the bootstrapping. So essentially, what we need for our setup is Hadoop for HDFS. Ganglia for the monitoring, Hive if you want to run but queries via Hive, but you don't really need it. You can use Q as well. TensorFlow if you need it. Spark is probably what you're going to use. And nothing here is interesting. Someone is joining. Great. Okay, so let's put these selections. You need to understand that every technology you add will be automatically installed. However, it will make your bootstrapping time much longer because after the machine is up, each application is being installed for you. Okay. You have an ability to use master nodes. If you remember the architecture, allow me to put a slide around the architecture so it will be clear. Yes. Over here. If you remember, in slide EMR 3, we have a slide regarding the architecture. We have the yarn, the compute, which is Spark, and the storage. And you have master nodes, core nodes, and task nodes. And we discussed that master nodes are usually deployed as one, but you can use more master nodes to have high availability. Do you remember this section, or do you want me to review this part? Okay. This section, AWS Glue catalog, is very important. If you select Hive, you have two sections here. Use Hive and Spark table metadata. That means that all the metadata of Hive and Spark will be saved on AWS Glue, which is essentially a managed service that saves metadata for you. Why is that good? Assume a transient cluster, a cluster that goes up at night, works for 2 hours, and then dies. The metadata of each table can be saved 24/7 on an external service called Glue. And this time, this is good because the next time you load your cluster, the tables will be available. You don't have to do something special for that. Is that clear, or would you like me to go into depth? In depth?
Well, what do you mean tables will be available when you have the metadata?
It's just the metadata. Allow me to find probably a slide from data engineering course, Glue and Athena. Slide number, Glue. Here it is. We didn't cover this in this session, however, sorry, 1 second. I need to give myself permissions to watch my own content. Okay, slide number 32. What you can see here is you have many databases. You have the Glue data catalog. This is essentially allowing you to access any table from any technology to any technology. For example, Redshift EMR. Meaning you can run on EMR, select store from a table on Amazon Redshift. Is this concept clear?
Yes, it's clear. But
The metadata is deleted after terminates?
No, that's the beauty.
But
So if I do a lot of EMR cluster all the time, different metadata, different, I don't know, website or something like or something, I need to clean it manually.
So don't use Glue if you need to clean it. Use Glue for persistent metadata. Why is that good for? Example, you want a cluster for analysis. a 9 to 5 cluster. Each 9 o'clock, every day, cluster spins up, and you want all the table accessible to be accessible for your data team. When they go home at 5 o'clock, some of us go at 5, some at 2100, but let's assume 9 to 5 cluster. You want the cluster to die, but the metadata to be kept to be available for the next time to minimize the bootstrap time.
But the
Yes,
data itself is gone when the cluster.
Wait. So you're
unless
asking.
it's in,
So let's slow down.
yeah,
We discussed only about metadata, but
Yeah.
now you're asking, rightfully, but what about my data? Where's my data?
Well, if it's an S3, I mean, do you mean like a case where it's on S3, not on HDFS, like it's like a persistent storage?
Exactly.
So my question is, how much quicker the availability of metadata is such an influencing factor that it will be like, you know what I'm saying?
Yes, it's
Data
probably
is,
the most important feature AWS has ever created in EMR.
okay.
It's a game changer. It's why you use EMR over any other distribution.
Because of Glue.
Because of Glue. So this is probably the only reason why EMR is such a unique Hadoop distribution. It has a lot of advantages, but there are other distributions with other advantages, just to be clear and fair.
Okay, can I ask another question?
Yes. I'm here for your questions, my friend.
So if I look at this slide, so I have
Yes.
perhaps I should use Redshift. Why should I use Spark over, let's say, Redshift for running queries?
It's
on, let's say,
only a
terabytes?
matter of use case. Tell me your use case, I will tell you your architecture. This is just merely an example to emphasize the benefits of using Glue. If you ask me, the more common use case would be, listen, I have 2 EMR clusters, one for analysis, one for production, but I want the analysis team to be able to query the production data. How would I do that? Using Glue.
Yeah, but my question was, should I query the data using the Redshift engine or Spark? How do you know which one would be?
So this is a matter of architecture. If your use case is purely SQL, there's really no need to use EMR at all. Use Redshift and use Athena.
Okay.
By the way, if you use Athena and Redshift, you still can use Glue. So if you change your mind and you want to switch to Glue, you're good to go. You understand now the importance of Glue?
Yeah.
Essentially, Glue is... One second, Shai, please.
Sorry.
Just to answer his question. Essentially, Glue is the glue that connects all the technologies together.
Brilliant.
How you use it is up to you in your use case. Shai, please.
Yeah, I have a question about EMRFS. It can come from S3 and it can come from the HDFS, right? I can take the data and transfer it to Hadoop and control the data in my cluster, or I can work with S3 that it's also has the ability to be like HDFS. What's the downsides? What's the upsides of doing it?
Wow,
I understand.
Have you been to the second lecture? The second lecture talks only on this.
Okay, so maybe I need to.
I don't mind reviewing that in the end of the lecture if you like.
Just like a sentence or two, not like.
Generally speaking, as a rule of thumb, always use S3. As a rule of thumb.
Oh,
In specific use cases, well, for example, temporary data, for example, speed is an issue, but not all types of speed. I'm talking about latency, that you must have the answer relatively quick and you cannot wait for the bad job to finish. Because in S3, you need to pay latency time for migrating the data from S3 to your cluster, and then another time for processing. So sometimes you want to skip the latency part by having the data available now. Downside, the throughput of the disk of HDFS is limited to what you assigned as a resource.
okay. I think I'm okay.
Allow me just to, because it's a simple.
I'll recap it again.
No,
Thank you.
no. It's a simple notion what I said. Allow me just to show you the relevant example, a relevant slide, so it will be easier. I'm not going to repeat the entire 1.5 hour now, but if it makes sense, because if other people are here, maybe they also need the recap. So we talked about S3 and HDFS. 1 second. So one, we discussed about the latency and the throughput. This is clear. Then we discussed about the scenario where you have a network overhead. This is the latency again, where you have some data on HDFS and some data on S3. You need this data available here, but you don't really have it, so you need to do shuffling, which is a pain. Sometimes this is standard HDFS deployment with a master and a core, and you have a scenario where a node is failing or a disk is failing. Then you would need to rebalance all the different data on all the different nodes, which rebalancing takes time. It's painful. So you want, for this reason only, to put all the data on S3 to avoid the rebalancing when you scale up and down as much as you like.
You can do it also in HDFS, but it's more resource, like
more time consuming and more resources.
Time consuming and more resources.
However, in specific cases, I will tell you, let's do this, HDFS, because we can optimize it, we can tune it, we can configure it as we like. We're experts. We, as in this group. S3, on the other hand, was designed for parallelism, meaning give me one cluster, give me 1,000 clusters, give me one cluster with 1,000 machines. I can give a service to all of them in parallel. While in HDFS, this ability will be limited to the amount of disk you have on your cluster. So far, so good? Other than that, there are some architectural pros and cons for each one of them, so you're more than welcome to review that later. But in a nutshell, I gave you the highlights, okay? Okay, so this is clear about the metadata now. We had this for using the tables on our metadata. Here you can have special configuration. If you remember on part 3, we discussed about different configuration. For example, executor memory or maximize resource allocation. I gave you very cool articles about Spark tuning and how you could learn this by yourself and do it. It's very time consuming and requires a lot of knowledge, but I gave you the basics here to start. It will save you months of work. So this is the steps. You should know that you can run steps once the cluster is bootstrapped. What is that? For example, Spark application. You provide a Spark application and you provide options and you give a jar that holds the code to run on your S3, and you can provide actions, some sort of logic of what to do if the job fails, and so on and so forth. So is the concept of step, naturally it's optional. Steps, is it clear? Great. So we're moving on to the hardware part. This is where everybody gets it wrong and messy. There are two types of cluster compositions. One is uniform instance groups and one is instance fleets. This is probably the most confusing yet powerful option you have for EMR. This essentially allows you to dictate a family of machines, instance types. For example, M5, M4, R6, and so on and so forth. However, you want to avoid that. You want to use uniform instance groups. This means you use one instance type for everybody. Why? The secret, in a nutshell, is configuration simplicity. You want to simplify your configuration by an order of magnitude. And I do mean an order of magnitude. Okay?
But doesn't it mean that a master that doesn't need to be like as strong as
No. You can
no?
play with the master, but my recommendation is a rule of thumb, same size for everything.
Oh,
As a rule of thumb, yes? But naturally, per use case, I will tweak it a little bit better. Okay. Networking is a simple networking, VPC, subnet. There's no really need to go deep into that. By the way, don't use EMR serverless. Side comment. If you're not an expert on EMR deployment, I strongly recommend to avoid using spots. This will save about 80% of your cluster deployment costs and your AWS billing, but this really assumes you know what you're doing. So try to avoid this as much as possible. Is this concept clear? Do you have any questions before I proceed? No. Okay, so as a rule of thumb, the minimum setup of a cluster is 1 for master, 2 for core nodes. If you need more, you can put here as much as you like, you can put here as much as you like. Which type of machines you want to put when and where? I would put more here, less here. Why is that? Because I want to preserve the ability to auto-scale. And if you auto-scale on your core node, it will take a lot more time because of the rebalancing action of migrating data from each core node. Okay? Questions? Okay. Notice this button, you can add another task group. This is only useful if you want to have different auto-scaling policies, different policies per task groups like start, stop, auto-scale, yes, no, and stuff like that. Notice you can configure your storage here and you can choose your machines. I highly recommend using R instances. Any type of R instances, just check the costs first. For example, R5 to extra large with 8 CPUs and 64 gigs, and going up from here. Auto scaling. You can apply auto scaling. I highly recommend to avoid this for your first clusters because it's non-trivial to understand what you're doing here. Auto termination, you can provide a timeout for the cluster to die, say 6 hours, and because sometimes people forget to close the cluster. This is very bad because it costs a lot of money. Naturally, you can set the root, the volume for more than 10 gigabytes. Let's put that 1 hour. Cluster settings. You can give a meaningful name here, my first cluster. It doesn't have to be unique. I mean, each cluster could be called my first cluster. That's not a problem. You can choose to add log files to S3 and you can set up your own folder over here. You can encrypt the logs if you like. And you can add debugging data as well. You can add termination protection, which essentially slows you down when you terminate by asking you again, are you sure you want to terminate? Please disable termination protection. You can add here key values to identify your cluster and do some FinOps. MRFS consistent view is for read after write. Not a lot of use cases require this, but you should know it's available. Linux version, you can do a custom AMI. Not recommended, but it's doable. Bootstrap action. Bootstrap action is essentially adding automating steps of what to run on the cluster while it's being loaded. Differentiate between steps, which happens after the cluster has been fully deployed. There's a major difference. It's running time. Is the difference clear?
Yeah, but it's just a question. The jar files that I'm importing, it can be here, right? If I'm not mistaken. Like if I import
I
the
usually
script.
put it on S3. I hardly use bootstrapping, but if I have to, I make sure everything is on S3 as much as possible.
Okay.
Yeah, I mean, okay. Sorry for the accidental Hebrew. First, fourth page. You should know that you can add a EC2 keeper or login via SSH, but you don't really have to. That means if your cluster is running automatically and no one is logging in, you don't have to put a keeper. So this enables you the possibility to further protect your cluster, which is quite useful because no one will be able to log in. Permissions. You can create your own custom role by a standard IAM role and provide any type of permissions for the instance, for the email service itself, for the auto-scaling policy, and so on and so forth. You can define a security group, which essentially talks about security configuration, and security group, which essentially talks about securing your cluster in terms of encryption at rest, encryption at motion, and open ports for the masters and for the current tasks. Questions? Okay. The deployment manual combined with a deployment manual we have on our community website over here in data engineering, AWS EMR. One second. Installing AWS EMR cluster tutorial. You have everything we discussed in this session with some small explanation about each technology, if you remember this one, this list over here. And you have a wizard with screenshots and selection and basic explanations of what we discussed in English. And essentially, this makes your life easier. It's not a lot of understanding to the blog, but it's trying to simplify the process of your first cluster. Because based on my experience, the first one is the most difficult one. It's rather detailed with some internal links and some video, which was quite useful. I'll even put the video of this session over here, and talks about the security groups we discussed. And you should know that there's a button called AWS CLI Export, which essentially gives you a command line CLI command of bootstrapping your own cluster. So let's review this for a second. This will essentially tell AWS EMR to create a cluster with an auto-scaling role and a list of applications and EC2 attributes of this role and this subnet and this security group. Basically everything we configured in the wizard, including size of disk, instance type, number of cores, configuration, for example, Glue metastore, and scale down behavior, and terminate at completion, and region, and so on and so forth. So all this lecture combined with this blog should save you about 2-3 months of work. And I hope this session and this entire course were helpful because it pretty much concluded what I wanted to convey as a message. Now would be a time to understand anything you haven't understood throughout the last 4 sessions. If you have any follow-up questions, things which are not clear from any of the lectures, I would be happy to go over it. Okay, going once, going twice. Solved. So guys, it's been very lovely to work with you on this EMR crash course. I hope you can benefit from this. Did it free of charge, out of fun, pure fun. I like to lecture about data and I like to engage with the community. You're more than welcome to engage with the website and to consume more content related to your work. You're more than welcome to ask me questions. If I'm available and free, I will be happy to answer anything you may have. That's it, basically, unless you have any more questions.
Yeah, I have some questions. So,
yes, please.
Yeah, just curious about, do we have a limit on the HDFS disk? So,
you can sign as much as you like. I mean, there's always a limit, but it's quite big.
like 100 gigabit or something like.
You can as big as you can afford, and much bigger.
Oh, okay. Oh, yeah. Okay. Also, regarding if you deploy data on S3 or HDFS, is a difference over the performance? So.
Yes, there's always a performance difference. As a rule of thumb, prefer to work with S3, but in some case, HDFS will be much faster.
Much faster. Oh, okay.
In some cases, but as a rule of thumb, always start with S3.
Okay. Yeah. Yeah. Sorry, I have another question. For EMR to run a task, so we need to deploy code on the cluster, right? So every time we create a new cluster, so we need to do that like over and over.
Can you repeat the question?
Yeah, we need to deploy the code to EMR, right? So
Yes.
normally, how we're gonna do it? We do it every time when we spin up a cluster?
You put the code on S3 and you use an orchestration tool like Airflow to spin up a cluster, set up a step that says, EMR, please run this code running on S3.
Oh, okay. All right.
Can I follow on this, on your comment? You said you used the Airflow, and I remember, and then we discussed it in another meetup that you about discuss Airflow, and why don't you use Glue for scheduling? I mean, what's the advantage of Airflow?
Don't.
No?
Highly recommended to avoid it. Allow me to share
Airflow?
screen again. If you remember the slide about EMR, about Glue, can you see my screen?
Yes, yes.
So you have the AWS Glue data catalog, and there's another service called AWS Glue ETL.
Yes, okay. Right.
This is for the orchestration. Avoid it.
Okay.
Why? One, it's a tool which is rather limited and a toy compared to other deployment options, orchestration options. Two, vendor lock. You want to be able to switch to another distribution of Hadoop should the situation require it. I mean, it's okay to start in AWS Glue ETL to minimize your learning curve because it helps you generate code. But as a rule of thumb, if you want to become an AWS EMR expert, avoid using that. That's for purely beginners and less.
It's more because Airflow can deal with more open source things or work with bigger community.
Airflow is more open source. You can connect anything to it. The community in Israel has adopted it above and beyond.
I know. Yeah.
And as a rule of thumb, you want to be able to understand exactly what you're doing and how it was configured. And you want to control costs and you want to control storage and so on and so forth. If you find yourself in a situation where you have absolutely no idea what is going on with your cluster, now would be a good time to call me as a consultant and I will be happy to help. But I'm not trying to sell my skill. I'm trying to say, as a rule of thumb, Glue ETL is a good starting point, but you want to avoid that as much as possible. I gain nothing by saying that, but to be fair, it's not something I would recommend to anyone.
Yeah, regarding Airflow, sorry, I have a question about Airflow. So normally, how are you going to set up an Airflow server? Where are you going to set up? So are you set
On
up
EC2
somewhere?
machine. On EC2 machine on AWS, you can install it.
Oh, okay.
Nowadays, installing Airflow is rather simple compared to what it was in the past. And you can do it within an hour if you know what you're doing. If not, a day or two.
Oh, okay. So
And
basically,
again,
we set
you
up
can,
by myself ourselves, right? On
y-
AWS EC2.
yes, you can use the Airflow managed service on AWS called MWAA, but
Oh,
it's probably
MWA.
the worst
Worst.
managed service that was created by AWS.
Oh, really?
Yes, unfortunately, when they mess up, they mess up.
On the last summit in AWS, was there any new things about it or something that make it better?
Probably, I don't really do announcements on AWS simply because I learned really fast that the announcements are only available in a year or two. And you need to let the market adopt the technology and let the bugs be exposed before you start using that. Sorry. As a rule of thumb, thank you. Only use mature AWS services unless you have a really good team that can experiment rather quickly and give you reports, or you're using an outside consultant for proof of concept. Just simply things you don't want to spend your time learning AWS. You want to spend your time moving your business along. I mean, it doesn't matter who you are, what you do. You have an agenda, you have an objective, you have a KPI. Learning AWS is not one of them. Even if you're a DevOps expert, you have tasks, you have milestones, you have sprints you need to deliver. So it's okay to experiment if you have time to understand new technologies once they offer, but the announcement, wait with them a year, always. And unless it's a super critical announcement that is very important to what you're trying to do right now, which is rarely the case, try to avoid it. That's my take. Okay, so just a reminder, guys, before I leave you to it, to those of you who missed the previous sessions, you can, sharing my screen, go back to Big Data Demystified Ninja, our community website, under Data Engineering EMR. You have all the past lectures on meetups in English, EMR Demystified Part 1 to 3. You'll have here, naturally, Part 4 as well. The slides are available there as well. Should you have any questions, please don't hesitate to tell me. I'm looking for volunteers to have a summary of each session. So if you can come across someone who is willing to help the community, let me know. Because I have lots of content that need to be summarized, and I see that on Google there's a lot of trend for searches and help regarding EMR. So I'm trying to help as much as I can, give all my knowledge for free and experience, but it's a lot of work. To generating content takes a lot of time. So if you come across someone who is willing to help, please let me know. Okay, guys, unless you have any more questions, now would be a good time to say goodbye. I will try to come up with new content, new content, and new courses and new blogs going forward. I have a couple of ideas. If you have some needs or requests, just shoot me an email. Not via meetup.com. It's terrible messaging system. You have my email, my personal phone number in Israel, my LinkedIn, all the relevant links of YouTube channel and Meetup and so on and so forth. So please don't hesitate to contact me for anything.